In this video I'm going to show you how I put together lithium-ion batteries for use with RC planes. So this first step, I'm using copper braid to create bus bars, and so I'm soldering across the copper braid here about 3 centimeters from the end to create a solid link where I can cut through it later. If I don't create this, if I don't solder this in, when I cut it, it'll sort of frays. But if you put this solid solder, you can cut it quite easily. So I'm doing a vertical line of solder there, so that I can cut this in half as well. So here I'm just lining up 3 centimeters, and that's about the right size to go between 2 cells. And then with some tin snips, just cutting right through it. So then I'm going to turn it over, and I'm going to tin the other side as well. So the idea is to get lots and lots of solder into it, so that when we eventually press it onto solder it onto the batteries, there's so much solder in there it just takes. And the type of solder as well is quite important. I'm using eutectic solder here. It melts at around, I think, 180 degrees Celsius, something around there. So it's a much lower melting temperature than regular solder. So yeah, snipping it in half lengthways. And what I end up with is a approximately 1.8 millimeter thick by 3 centimeters long by about 9 millimeters wide. Perfect size for a bus bar for the lithium-ion battery. So I'm going to make 5 more of these. So I need 5 for a success. And I'm just adding extra solder here. These are the parts that's going to touch the cells. So next step is to scuff up the ends of the cells. And this is so that the solder can take to it easier. You need a nice rough surface, and then the solder will just feed into it a lot easier. If you don't do this step, it makes it a lot harder to solder to the actual cells. And so we'll just do the same process to the rest of them. Then this is quite important. These insulators will go on just the positive end, but it ensures that we don't get any shorts, because the positive end, that little tip at the top, is the only positive part. The rest of the cell is all negative, so we don't want to cross over there. And that insulation will easily, the plastic battery insulation will easily melt, whereas the paper will be fine. These cells are the Tenpower 50XG, if you were wondering. They're very good cells. Okay, now's the first scary bit. So you need a really beefy soldering iron to do this. So that's 450 degrees Celsius. And I got the fattest tip I can find on the end of this. I'll put a link to this soldering iron in the description. But you need a soldering iron that has high wattage, basically, because you don't want to have much time on the cell. You want to be on and off as quick as possible. So I'm preloading the iron with a bit of solder there, so the heat transfers fast. And look at that, like a second. So the negative end will take a bit longer because it's a larger surface area. But again, preloading the iron, and then straight on as quick as possible. Nice little pull. And that battery, or the cell, is barely warm. It will get a lot warmer when it's being run in a EDF jet than it ever will when you're soldering like this. So yeah, rinse, repeat that. Now let's load it up into the battery holder. So these are 3D printed battery holders. I will try to remember to put a link to them in the description again. And so we want to go positive, negative, and positive, negative, because we're going to create the series by soldering on the bus bars. So what I like to do at this point is, before we actually get the solder out and start, creating circuits and all of that, I get some insulation tape the same size as the bus bars, and I put them on there so I can route it through in my head. And so I'm tracing the way the current's going to move. So I know exactly where I need to put the bus bars. And that's where the terminals go on the end. So, the balance leads. I put the positive in first to get the gauge of how long I want the balance lead to go. And then what I'm going to do here is just feed it through to where it needs to connect to a cell. And then, so I get the idea of how long that piece of wire needs to be. So this one here, and this is actually the pin number 2 this one goes to. This needs to go that long, so measure it out and cut it. And then carry on, do the rest. So pin number 3 goes to this part here, and we don't solder to the actual cell with these, it's just the bus bar we solder to. This is how we get the measurement of how much is in each cell when we plug it into a battery checker. Snip that, so that's number 3. So the most fiddly part of all is connecting these. So of course you can just buy a pre-made cable and then cut the cables to size or lengthen them where you need to, but as it turned out I couldn't find any, so I had to make up my own. So this is how you do that. Snap those off, make sure you got the right amount, and then take each cable, strip them. Now it's actually really important to not strip too much off of these. You want about 1.5 to 2 millimeters. It'll be really difficult to actually put it in the little metal connector if you make it too long. As you can see here, so if you make it too long, it's not going to really crimp down. So that first one that I'm doing there, that's to crimp the insulation. There's probably a tool to do this. It could be actually that tool behind there. I did try with those, it didn't really work very well. So just doing it this way. And it works. Takes a bit of time, but it works. So insulation's clamped down. Give it a little bit more. Go on. And then clamp in the metal contacts. You have to make sure that bit there isn't too wide, otherwise it won't go in the connector. So now here's the important part. Make sure that you're going to route this through and put it into the right pin. So double check, triple check. I know that this one is pin 2. Yep. Pin 2 is, oh no, I'm pointing to pin 1 there is the top one. Pin 2 is the one that this needs to go into down there. Okay, so this is the point where I realized I didn't do pin 1, so I'm cutting up pin 1, and that just goes straight to the main negative. Give it a little bit of a trim. It's helpful, I find, to have a little sort of pointy, thin screwdriver to push those in easier. And then you have them all in. Now you need to strip the other ends and tin them. So you can take a bit more insulation off this end. Makes it a bit easier to work with, since we're just going to be soldering these to the bus bar. If you don't have a pair of these insulation strippers, I highly recommend it. They don't do every wire, but they do most. So much quicker. Give it a good clean. Heat transfers better when it's clean. And then you just want to tin every single one, so that when we come to actually soldering everything together, we don't have to have a load of solder in our hands. We just have everything pre-soldered, and we just push it together and heat it up, and then it takes. Nice and easy. So this is the advantage of making these leads yourself, is you can make sure that they're all just the right length, because usually the ones you get off the shelf that are already pre-done, they won't be the right length, and you end up having too short of a balance lead coming out. So here's the exciting part, the bit you've all been waiting for. So bus bars, making sure the bit with more solder is on, facing down. Take the insulation off for the guide, and make sure the iron is really hot and clean. And then I've got a pair of pliers so I can make sure it's in the right place. Also acts as a heat sink. And then you just kind of press on there, and you're going to feel the bus bar sink into the solder. That's how you know that it's gone all the way through. Same again here. So it's not a lot of time on there, and the battery, it gets a little bit warm, not very warm though. Like I said, like when you fly with these, they get a lot warmer than they ever do when you solder them together. And I've been flying with these quite a lot on EDF jets. They pull quite a lot of amperage, and they're doing perfectly fine. Of course, the reason why we have these copper braid thick bus bars is because you need the extra capability to deliver the amps through, because if you're going to draw 70 amps out of this one battery, that means that every single bus bar also needs to be able to handle 70 amps. So, you know, it's fine to use the nickel strips with the spot welders for lower amperage, but this pack here is intended for EDF usage, and it's going to be going up to 60, 70 amps. It's going to run in parallel with another cell, with another battery. So in total, 140 amps, with each one at 70 amps. But still, each bus bar needs to have the capability to deliver that much amperage. And these bus bars should be able to take about 90 to 100 amps. Most likely more, but they're rated at least at 90. So it's really handy having those insulation tapes, because I don't have to think. I've already done the thinking. Now I just need to solder and take off the insulation tape, replace it with a bus bar. So it's not very much time at all on each cell, as long as you have a very powerful iron. Don't try doing this with a 40 or 80 watt iron. You need a ridiculous wattage. And eutectic solder. All done. So check your work. .6 volts per cell. 21.4 in total. Perfect. All right. Now we need to make some XT90 connectors. So 10 gauge wire is what you need for this. You're about to find out the limits of this wire stripper. So they're about, what was that, 10, 11 centimeters long. However long you need it. I think 11 centimeters is enough. Yeah, here we go. 14 quid off Amazon. Yes. Yeah, we're just going to use the knife from now on. And as usual, you want to tin these as well. Okay, so you need to grab your XT90. You want the female end for the battery, not the male end, the female end. And then I find it useful to plug in the female end to a male when you're soldering, because of the intense heat when you're filling the wells up or the bullet connectors up, it can deform the plastic. Whereas if you plug it in, you make sure that the plastic won't melt and therefore the alignment won't go out. Just make sure you solder the correct end when you plug them together. So fill that with solder. On both sides. Nice hand. Yep, so positive, positive, red. Double check. And now it's simple as heating that up again and sinking it in. Beautiful. That's quite satisfying actually. So at this point is where you would make sure you put your heat shrink on, so it's ready to slide down. But if you're like me and you have the very fancy clips like this, you can just put that on at this point. There we go. So we're getting towards the end. Now is the last points where we're going to solder to the cells. So good solid connection. Should we check it? Yes. And last is the balance leads. So positive on first, and I'm making sure to have it on the inside. It makes it easier to route the cables as they come out. So this is pin 1 of negative. Again on the inside, not the outside. And now we have pin 2. So pin 2 goes down, and you want to double check to that bar there. Solder it on. Now we're going to pin 3. So pin 3 goes across the top to that bus bar. He's getting there. That one. Yes, that one. So yeah, tin it up if it hasn't got enough on there. And that one whilst you're at it. So that's pin 3. Now pin 4 goes all the way to the back and all the way down to the bus bar at the end on the bottom. So you're just working backwards from negative to positive when you go through all of these. Pin 5. Next one up is that one. It sounds complicated when you first try to make one of these cells, but then when you realize that the balance lead is literally just going one after the other in series to the next connection between cells, then it's very easy. You don't have to overthink it. Give it a bit of tin and solder. Great filming there. Okay, we're done. Let's check. So yeah, 21.4 volts, and on this one we actually have lithium-ion mode, which is good because the percentage is a bit more accurate. So 3.58, 3.56, that's all around storage voltage. When we fly, we can come down to even as low as 2.5 volts on these cells, but I tend to sort of cap it around 3, just to be safe. Or run an amp meter so you can measure how many milliamp hours you've consumed. That's the better way. So last thing to do now is to glue it all shut. So I tend to also glue between the cell and the 3D print after everything's done, just to give it a little bit of extra rigidity, because right now the only thing that's really holding on the top and bottom caps is the bus bars. You can just squeeze a little bit of super glue in from the outside, and it just gives it a bit of extra strength. But there we are. One last check. There is a bit of a gap there where the leads come out, but that's because 10 gauge is so flat. So that is how you make a 6S lithium-ion battery running Tenpower 50 XG. Thanks for watching.